Hello friends, today we are going to discuss regarding the hydrographs. Before proceeding to the hydrographs, let's revise some part of the hydrograph. Now there is a difference between the hydrograph and hydrographs. As we have studied that a hydrograph it is plotted against rainfall intensity and time. Time is plotted on the x-axis and the rainfall intensity is plotted on the y-axis here, and these bars are indicating the rainfall. Now effective rainfall hydrograph. Now what is effective rainfall? Part of precipitation that entirely contribute to the formation of direct runoff. It shows effective rainfall and initial loss. It also provides information on effective rainfall depth and duration, direct runoff volume, amount of initial loss. It can be used for the determining the effective rainfall. So also, if you remember, we have calculated the phi index and W index by using the hydrograph. So hydrographs are plotted against a discharge and time. So this is a difference between these two types of graphs. So today we are going to discuss regarding the hydrographs. Now hydrograph, if you see the record of river discharge over a period of time, which is Q versus T, that is discharge versus time. Now the river discharge can be calculated as a Q, which is A multiplied by V. Now A indicates the cross-sectional area of the river, and V is the river's mean velocity or average velocity at a particular point of its course. Now, also we are discussing regarding today storm hydrographs, which shows the change in the discharge caused by a period of a rainfall. Now, why to construct and analyze hydrographs? To find out discharge patterns of particular drainage basin. We have to find out how the drainage basin is reacting when the precipitation takes place. So the hydrograph help in that. Also, it help in to predict the flooding events and therefore influence implementation of flood prevention measure. So if you are having the properly plotted hydrographs of the drainage basin, so that can also give the idea regarding flooding events, and also we can take the proper prevention measures to avoid the mishaps. Now what is actually a hydrograph? So you can see here this hydrograph is plotted here, especially when you are plotting regarding if you see this portion, this is a hydrograph, these bars, and which is plotted against a precipitation or rainfall in mm and time on the x-axis. But curve this curve it is called as a hydrograph, and which is plotted against runoff or a discharge, okay, in cubic meters per second against the time. Okay. So what are the parts of this hydrograph that we are going to see? What is it? It is a plot of a discharge against time. Now it has three regions: rising limb, crest segment, and falling limb. If you see here, starting from this point, okay. So this is called as a rising limb. Then this is a crest point, or it is called as a peak discharge, and thereafter it comes down again, and it is a falling limb. Nature of hydrograph depend on rainfall and watershed characteristics. Now this shape of this hydrograph, that depends upon the nature of the watershed characteristics. It means that what type of the drainage basin is available there, what type of stratum is there, what type of vegetation is there, okay, what type of slopes are there. So all these things are going to affect the hydrograph. isolated storm results single peak hydrograph, and complex storm yields multiple peak hydrographs. So uh, there are various types of storms are there. If a single isolated storm, if you take, it will give a single peak hydrograph. But in case of the complex storm, you can find out a different yields, which is vertical peak hydrographs can be obtained. So here again, before proceeding, we are revising this frequently in the coming this session. So right from the inception of the this rainfall to the this crest, a time interval, it is called as a lag time. Then you can see here, this is a normal flow. Below this, it is called as the base. Yeah, you can see the groundwater flow, right? This is a storm runoff. So we are going to study in detail regarding this. Now the flood hydrograph, again, if you see here, what are the various elements are there, you can see again here. So this again, these bars here, which shows a hydrograph, which is plotted rainfall in against the time, which is hours to from start of a rainstorm time. And this hydrograph, it is plotted on y-axis discharge in meter cube per second, and on y-axis time. Now these blue color titles are there. It is the components of the stream stream flow, and this red terminology, it indicates the elements of a hydrograph. Now, as we have seen, this is a rising limb of a hydrograph, and from a peak point or peak flow, or which is a crest, it is the graph comes down again. So it is a falling limb, or it is also called as a recession limb. Please remember these terms. Then here, uh, this flow which is occurring during the storm. Okay, so below this, these two inflation points, this is called as a base flow, right? Then again, in the river basin, or in the that stream basin, it is the interflow, and again, which is flowing on the land, it is the overland flow. So these three components also we have to remember. Now rising limb, ascending portion representing rising discharge due to gradual increase in flow in stream. Slope depends on storm and the basin characteristics. Again, if you see this particular, most of times you can find it is more stiff than the falling limb or recession limb. Rising limb, you can see it is a more having the more steep slope than the recession limb. If you see the earlier graph as well, you can see this is more steep than the falling limb. Then crest segment, inflation point on rising limb to falling limb. It indicates peak flow. It is controlled by storm and watershed characteristics. Multiple peaks due to occurrence of two or more storms of a different intensities in a closer interval. If you are just we have discussed, if two or three more storms are there in during the, so different peaks can be observed there. Then falling limb, or which is called as a recession limb, from point of inflation at the end of the crest segment to the base flow. Inflation point indicate the time at which rainfall stopped. Shape independent on storm characteristics, but dependent on the watershed characteristics. Okay, so here watershed characteristics are very important in the shape of the hydrograph. Now again we'll revise the points that we have learned regarding the hydrograph. It is a graph which is plotted discharge in meter cube per second on the y-axis, and time on the x-axis, the duration. Now hours from the start of the rainstorm. Then if you see the hydrograph, so you can see the rainfall shown in the as a bar graph. So you can see, if you see the hydrograph, these are the bar graphs out there, and which are on the y-axis. It will be rainfall shown in the as a bar graph, and time interval will be same. Then what is the difference between hydrograph and hydrograph? You can see this hydrograph is in the green color. It is a discharge in meter cube per second as a line graph. Okay. Now rising limb, the rising flood water in the river. So when the precipitation take place, the discharge you can see that increases, and it will reach a some point. Okay, so that particular you can say part, it is called as a rising limb. Then peak flow, which is a maximum discharge in the river, and thereafter recession limb or falling limb water in the river water. So that water level drop is there, or you can say discharge drop is there. Now again, basing lag time, the time difference between the peak of the rainstorm and the peak of the uh, flow of the river. So that we'll have to remember. This is a basin lag time. Now base flow, you can see here in between these 2 points there, where you can see start of this rising limb and end of this recession limb. So joining these 2 points, so between this you can say this is base flow or the groundwater flow. You can say normal discharge of the river, right? Then overland flow and interflow, as we have seen here. The overland flow, it is a volume of water reaching the river from surface runoff. That's why it is called as a overland flow. Then interflow, volume of water reaching the river through the soil and underlying rock layers. Here, this particular part, and GW here stands for the base flow or the groundwater. The overland flow plus interflow plus base flow, that is forming the stream flow. So this is very important to remember. Also we'll have to observe this thing in the numerical examples, or which is called as a total runoff, which is called as a total runoff. Now let's have the again one more glance on the hydrograph vocabulary. So you can see these inflation points are there, recession is there, base flow, falling limb, rising limb, crest. So rising limb, falling limb or recession, the rising limb and the falling limb are separated by the hydrograph crest, and the limbs are separated from the recession by inflation points. The rising limb typically is stiffer than the falling limb. As I have stated earlier, that rising limb is more stiffer than the falling limb. The only steady contribution to the water in a channel during dry spells is coming from subsurface flow, the base flow. During a storm flow in the stream increases due to runoff, then gradually decreases to some minimum value. The minimum is from base flow. Also, if you see this, observe this particular graph. When rainfall starts, some gets caught in the retention storage. Some part of the water is retained storage. Depressions, retention storage depressions, where it will be evaporated again, but some enters into the ground. So we call it as a infiltration, including some from detention storage as well. where it will contribute to the channel flow at some later point. So we have to remember this part as well of a hydrograph. So here, this particular part. It is a regarding the depression storage. Regarding this is a detention storage, and here it is indicated in case of the hydrograph. It is showing the infiltration there. So, friends, today we are gone through the various terms which are associated with hydrographs, and hydrograph, it is, as we have discussed, it is used for the taking the various measure. If you are having proper study of the hydrograph, then we can find out the various measures against the flood. Not only that, again in coming lectures we are going to cover regarding unit hydrograph and associated numerical examples. So friends, so thank you very much for joining today's lecture.